All right, so on Thursday and Friday, we did solving radical equations. And Thursday was what I would call the easy day, in quotes, because it was a radical equals a number. And so squaring both sides to get rid of the square root symbol or the cube root symbol or whatever, taking the correct power and then solving to get your answer. Whereas Friday, we usually had a variable, either a variable inside and a variable outside of the radical, or we may have had more than one radical, which are, in my mind, the most difficult. So are there any questions on solving the radical equations? All right. So today we're going to solve equations that are in quadratic form, but are not quadratic equations. And you'll see what I mean here in a minute, I think. All right. So when we say that it's in quadratic form, basically what we're looking at is the first term and its variable is going to be the square of the middle term's variable. And the last term is going to be a constant. So what we will do is we will make a substitution to get the equation in the form ax squared plus bx plus c equals 0. And then we can solve either by factoring or use the quadratic formula or any of those, the square root method, any of those methods we used in lesson 48. Excuse me. All right, so problems are going to look like this. Like this. There we go. All right. X to the fourth minus x squared minus 2 equals 0. Our second example is 3 over x plus 1 squared plus 2 over x plus 1 minus 1 equals 0. And then x to the sixth equals 1. And I think I'm going to need a little bit more room, so I'm going to space that last one down a little bit. That should be enough. All right, so the first thing we want to look at for problem number 1 is the variable in the first term is the exponent double the exponent in the middle term? Yes. So what we can do is we could make a substitution. We could say, I'm going to let w equal x squared. And if w is equal to x squared, then w squared would be x to the fourth. And so I'm going to substitute w for x squared and w squared for x to the fourth. And now, is that factorable? Can I factor? So factor into w minus 2, w plus 1. which means W minus 2 would equal 0. W plus 1 would equal 0. And if I solve that, I get W equals 2 and W equals -1, but I really don't want to know what W is. I want to know what X is. So now I have to substitute back. And W was the same as X squared. So this is X squared equals 2, and X squared equals -1. How many solutions am I supposed to have for this fourth degree polynomial? 4, right? So when I take the square root, I have to remember that I get both positive and negative values there. So I get positive root 2 and negative root 2. And for the other one, I get positive and negative square root of -1. And what is the square root of -1? I think you're right. So there are my 4 solutions, my 4 answers. All right, letter B. And I'm always going to use W for my variable when I make that substitution. So in this case, what would I want W to equal? Kind of hidden in there. But W is going to be 1 over X plus 1. And then W squared is going to be 1 over X plus 1 squared. So I get 3W squared plus 2W minus 1 equals 0. And we could factor this one using the slide method. I'm going to show you another way. And if you don't like it, too bad. But it's just a different way if you don't like the slide method. And I'm going to use it with this method with this problem because how many different integers do we know that we can multiply together to make 3? Just 3 and 1, right? And to multiply to get to 1, well, actually -1, we have to have a positive and a negative. So I'm going to think about this kind of backward foiling. To make sure I get that positive 2. Okay? So I know when I FOIL, I take 3W times W, and that gives me 3W squared. I would take 3W times 1 and 1 times W. And I need that to be positive 2. And I know I need 1 positive and 1 negative because I have to have -1 at the end. So should I put plus 1 here for 3W plus 1, or should it be 3W minus 1? And if we say that's minus, then this one has to be plus, and now we can double check. 3W times 1, that's 3W, and minus 1W, that gives us 2W. So that's the way we want it. There are times when this method works really well and times when it doesn't work well at all. When I was your age, and slightly younger, that's the way we factored all the time, and it wasn't fun. Now I'm going to take and set each of those factors equal to 0. And I get W is equal to 1/3 and W equals -1. But again, I'm going to need to substitute back in 1 over x plus 1 equals 1/3. 1 over x plus 1 equals -1. And to solve this, I have a couple of options. I'm going to choose cross multiplying. So I'm going to take 1 times 3 and x plus 1 times 1. And I'm going to move that over a little bit. There we go. So this would be 3 equals x plus 1, or x equals 2. And the other one, again, if I cross multiply, I'm going to think of that as -1 over 1. So I do 1 times 1 and -1 times 1. If I add x and subtract 1, and I'm going to circle both of these, but really for this one, I want to be careful because I can't have 0 in my denominator. And so I had 2 and -2. So, okay, that doesn't give me 0 in my denominator. I think we're going to be okay. Again, checking is never a bad idea, but because these are in that quadratic form, and we're not squaring things or taking dividing by a variable. And here it's set up that way to start. So we didn't divide by it. It was given to us that way. Your solution should be good. All right, last one. First thing I'm going to do is subtract 1. So I get x to the 6th minus 1. That doesn't look very quadratic. But if I let w equal x cubed, I would get w squared minus 1 equals 0. And now I have a difference of squares. So I'm going to write the factored form w plus 1 times w minus 1 equals 0. And before I solve, I'm actually going to make my substitution. And the reason I'm going to make my substitution is this x cubed plus 1 is now a sum of cubes. X cubed minus 1 is a difference of cubes. So all sorts of fun. The sum of cubes factors into x plus 1, x squared minus x plus 1. And the difference of cubes factors into x minus 1, x squared plus x plus 1. All right. So x plus 1 equals 0. That means x has to be negative 1. And x minus 1 equals 0. X would be positive 1. Notice I skipped the x squared minus x plus 1 and the x squared plus x plus 1. When you have a sum or difference of cubes, this second term, the x squared, the quadratic, has to be solved using the quadratic formula. And the reason it has to be solved that way is you're going to get complex solutions. So for this one, I would take the opposite of b. In this case, b is negative 1, so the opposite of negative is 1 over 2 times a, which is 2, plus or minus the square root. Got to move this. There we go. B squared minus 4ac all over 2a. What is negative 1 squared? Yes, 1. 4 times 1 times 1. 4. So I have 1 minus 4. Which is negative 3. So to get rid of that negative, I'm going to put an I outside of the square root symbol. And you can put it wherever you want. I'm going to do it this way. So here's one solution. Here are 2 more solutions. Here's a solution. And we're going to do the quadratic formula on that last quadratic there. The opposite of b over 2a plus or minus the square root of b squared minus 4ac over 2a. And the interesting thing is, oops, a is 1, so 2 times a is 2. And this won't always happen. It just so it happens because the quadratics, the only difference is the negative on the b. So the only difference in our answer, one is 1/2 plus or minus I times the square root of 3 divided by 2. The other is -1/2 plus or minus I times the square root of 3 divided by 2. Whew. Mr. Gingrich, these are fun. You can admit it, it's okay. Or not. All right, so your assignment, there was one typo in the assignment that I want to make you aware of. You're going to do 2 through 30, the evens on page 339. Number 30, the middle term, just as in parentheses, I think it doesn't have an exponent, but it should be to the 1/3 power. And that will make it quadratic. So if you want me to, I can scoot that up just a little bit. And on Friday, if you didn't look at the notes or the video, I mentioned that if you open to the very back page of your textbook, there is a web address that is actually a answer key. And I think it shows work on how to get to the solution. So rather than me writing up all the solutions all the time, it's a good place to check. So that's available to you. But if you open to the very back, inside of the back cover, there should be 2 websites there, Biff J. Biffson, something about Biff J. Biffson. What's that? I'll show you here just a second.